Yes. Once again, good morning, students. You can see we have studied already Fourier series. Next, we have studied Fourier transformation. We have seen the applications, we have seen the formulas, and we have seen the how easiest part we can easily solve the Fourier transformation, and which is of the interval minus infinity to infinity. So it is a vast applications we have in the Fourier transformation. Okay, students. Now here we are going to study the half of the transformation. Transformation, it is like a half range series that what we have studied. Same way here we say it as the half transformation, or it is divided into two, or they have two parts, that's Fourier sine transformation and Fourier cosine transformation. Is it clear? So in this we are first have given the formulas. Fourier sine transform formula is given by, so f of s, this small s is nothing but the sine. Okay, so fs of s is equal to integration 0 to infinity f of x sine sx dx, and we have its inverse, very important, which is very helpful to evaluate the examples, to deduce the examples. We make use this for all the examples. Maximum examples we are going to use inverse Fourier sine formula, which is given by f of x is equal to 2 upon pi integration 0 to infinity fs of s sine sx dx. Is it clear, students? So same way, this is a half series, therefore the interval we are going to take from only 0 to infinity. Please remember this. For the Fourier transformation, we used to take full interval, that is from minus infinity to infinity. So this is a half transformation, therefore the interval is divided, and it is going to become 0 to infinity, that you remember. And next we have Fourier cosine formula is defined as like this: fc of s is equal to integration 0 to infinity f of x cos sx dx. Is it clear? Next we have inverse Fourier cosine formula, which is again very important. In maximum of the examples we take the inverse. This will help to you to deduce the equations and then evaluate the equation. For such questions we use the inverse, that is given by f of x is equal to 2 upon pi integration 0 to infinity fc of s cos sx dx. So please note down this formula, students, very important. Whenever the word comes Fourier sine transform or Fourier cosine transform, please write down the formula. What I suggest for everyone is that if the exam is offline, all the formulas at the last of the page you write it down, Fourier series and Fourier transform, because these are the fixed questions for the final exam. So please remember, the question is fixed. Which question will come, we don't know, but fixed sine and cosine, one question will be there, and its inverse, one question will be there. So this is a fixed question, and you can see this is a course outcome of unit 3. So please remember this, students, very important. So this is CO3, what we say. So what you are going to learn from all these units? Yes, they are nothing but the PO, that is post outcome. So what outcomes you are going to get? You are going to study transformation, how the transforms takes place. We have seen, yes, student, that all things we are going to study, and you are going to gain the knowledge. So you can see the first example we are going to go with the this one, that is find Fourier sine transform of f of x is equal to e raised to minus mod x. Okay, so we'll just find the Fourier sine transform taking this f of x, but to evaluate, see, students, very important. Every time this question will come, and hence evaluate this integration 0 to infinity x sine, yes, mx divided by 1 plus x square dx. So whenever such questions will come, yes, evaluate, or they will tell you inverse Fourier sine transform, right, or deduce the equations. Such questions we are going to use the inverse. By only using the inverse we can simplify this, evaluate this problem. Is it clear? So I think all of you are ready to simplify this. It is quite easy here, students. Just graphically, I will show you for this example. It is not required for only your understanding. I'm going to show the graphically. So you can see the where is the variable is there. Here, mod x is the variable. Already, I think you have come across. If I take the function f of x is equal to mod x is there. So you can see the graphically. This is x-axis and this is y-axis. Yes, it is not required in the exam. Don't waste your time drawing this in the exam. So you can see this is nothing but y is equal to mod x. So what I will substitute x is equal to this is 1. I will substitute x is equal to 1. See automatically y is also 1. So means we get this line here. This is the point. Similarly x is equal to 2, y is equal to 2. Yes, x is equal to 3, y is equal to 3. So like this we get the straight curve. And we say this curve is nothing but the f of x is equal to mod x. Okay, now I will substitute minus 1. Okay, what I am substituting? X is equal to minus 1. But you can see this is mod is there. So y will be plus 1. So dot will come here. X is equal to minus 2, y will be plus 2. So like increases and we get the straight line. So this is the function f of x is equal to mod x. Similarly, yes friends, so what I was telling you is that similarly if you take the function f of x is equal to minus mod x is there. What this means? It is exactly reverse like this. We are going to get x-axis and this is going to be y-axis. This will be 0 origin, right? Now you can see this is second quadrant and third quadrant and this will be fourth quadrant. So what I will substitute here friends? Equal to minus mod x. I will first substitute x is equal to 1. But you can see automatically this is become minus 1 because minus is outside the mod and therefore minus 1. So y will become minus 1. So you can see here this is minus 1 minus 1. So dot will come here. Am I right? So similarly if I put substitute x is equal to minus 2, right? Okay. Then you can see mod plus again outside minus is there, y will become minus 2. So like this we get this straight line where x is minus, yes, negative sign is there, y is also negative. Therefore, this curve will come in the fourth quadrant. Okay. Now I will substitute x is, sorry, minus 1, minus 2. So the curve will come in the third quadrant. Now I will substitute x is equal to positive plus 1 if I substitute y is getting minus 1. Similarly, if I take x is equal to plus 2, but then this is mod 2 is again 2, then minus 2, so therefore it will come in the fourth quadrant. So like this, just for your understanding, I'm just telling you, it is exactly reverse. The image you are getting is reverse. So by using this function now, I'm going to solve this. Okay, so this part is only for your understanding. What you are going to simplify in the example, I will show you. Right? We are going to write the first formula. Please remember, whenever you start in the Fourier series, Fourier half range series is there, Fourier transformation is there, transformation is there, Fourier cosine transform is there. First, always remember, please write the formula. See, I think in the exam, some of the students they have not written, they have just directly they have solved. Yes, you may get wrong also. Yes, so now we'll simplify the function. So already the function is given. Always you can see as front function will be given, just substitute. So this is equal to integration 0 to infinity. I will substitute this is e raised to sine sx dx as it is. But you can see we don't have any formula for the mod. It will become e raised to, yes friends, I'll just simply remove the mod. So it will become e raised to x dx. I think you know the formula. Yes friends, please remember this all formulas. I think you should make a note. Yes, integration e raised to ax sine bx. I think we have used more than 2 3 times this formula, so please remember this is e raised to ax divided by a square plus b square, right? A sine bx minus b cos bx. Please use this formula. In this example, you can see from this a is equal to minus 1 and b is equal to, you can see students, it is yes. Okay, so now we'll substitute one by one. So this is equal to e raised to minus x, because a is minus 1, so we can see here minus 1 divided by, you can see here a square, or I will substitute a as minus 1, therefore this will become minus 1 plus b square. B square is, b is yes, so therefore this will become s square. Okay, a is minus and b is yes. Remaining terms as it is. B is again yes, cos yes x. But please remember this is integral, therefore it will be from 0 to infinity. Just I will take it equal to this side. Okay, so I think you are familiar with this now. Okay, now I will simplify one by one the value. Simplify the upper limit, that is x is equal to infinity. So here again, please note down another very important formula, students. Very important, because in all these sine form, yes, we are going to use this e raised to minus infinity. So this I can write it as 1 divided by e raised to plus infinity. Minus I have made plus. It will become exactly the reverse. That is what we have done here. Minus also is exactly reverse. So you can see e raised to infinity. So you can, infinity into anything is infinity, right? And any value to the power infinity is also infinity. Please remember this, students. Okay, so 1 divided by infinity. Yes, students, can yes, you are right. This is 0. Please remember this, students. Okay, now you can see x is equal to infinity means e raised to minus infinity will become 0. The part x is equal to infinity will be 0. So I'll substitute here 0. Okay, next minus. Okay, now I have to substitute x is equal to 0. Now you can see e raised to minus 0 is nothing but e raised to 0. So e raised to 0 is nothing but, yes. And anybody tell me what is e raised to 0? Or this is equal to 1. So I'll just take this as 1 divided by minus 1 square is written as square plus s square. Okay. Now again in this bracket you can see here, students, I'll substitute x. Please down all the formulas I am writing here once again. Sine 0 is what, students? Please anybody unmute and tell me please. Sine 0 is, yes, 0. So I'll substitute here 0. Then we have minus, yes. Okay. Next we have cos. Cos 0. Yes, please, friends. Cos 0. What is cos 0? It is 1. So let's multiply here 1. So this is our integral. Okay. Now further simplify this, friends. You can see here this is equal to minus into minus. So there is 1 minus is there, very danger person, and here 1 minus is there. Minus into plus. Okay, then we'll write this yes into 1 is yes, divided by, you can see 1 square is, I will just write 1 plus yes square. Is it clear, students? So this is our fs of yes is equal to yes divided by square. Is it clear? Okay. Now this is our Fourier sine series, or FST. What is FST? Fourier sine transform. Is it clear, students? So this is our Fourier sine transform. Okay. Then what we have to find? Yes, very very important. We are going to hence evaluate. Yes, we are going to evaluate this integration 0 to infinity x sine mx divided by 1 plus x square dx, students. Okay. So for evaluating this, as I said earlier, that we are going to use, yes, by inverse Fourier sine transform. I think transforming come across the films, you have seen the films also transforms, right? The vehicle is going to change into some robot. Yes or no, friends? So that this is what we have the transform. So we are going to transform this function into this, that is integral 0 to infinity x sine mx divided by 1 plus x square dx. So definitely from again from that robot, it is again going to transform into vehicle, right? So it is like inverse. There also inverse exist. Am I right? Yes. So here in the example also we use the inverse. So you can write down the formula for inverse Fourier transform. Yes, friends, you can see here inverse Fourier sine formula is given by f of x is equal to 2 upon pi sine sx dx. So this formula you use here. Is it clear? So I'm going to use this formula here. Yes, friends. So just write down the formula here. So that is fx. This is also written as like this. F inverse yes. Okay. No problem. So this is equal to 2 upon pi. Yes. Integral 0 to infinity fs of yes. So please remember, many students will make mistake in this that I am going to repeat. Whenever you write the Fourier sine formula, integration will be under dx. Am I right? But some of the students are making mistake. First Fourier sine transform formula, I can see ds is there. Integral is under ds. So this common mistakes what students will do, but please you don't do such mistakes. Is it clear? So now I will substitute f of x value that is given already, e raised to minus mod x is equal to, so I will keep 2 upon pi as it is, integration 0 to infinity fs of s, that is fst, that is Fourier sine transform. So I will substitute the values, that is s divided by 1 plus s sine s x d es runs. Okay. So I know my handwriting is not that good in the graphic tablet. It just spread, and sorry for that. But please try to adjust, right? And just understand the concept. That is what very very important. Okay, students. Again, here we must have, so for to solve this x sine mx divided by 1 plus x square dx, what I am going to do here, yes, again modify, change s to x and x to m. Okay, let us see. Yes, so I will take this 2 by pi on this side, so it will become, see, 2 will come in the denominator, pi will go to the numerator, so it will be pi upon 2, right, into e raised to minus mod, yes, this is x is there, what x is going to change, x is going to change to m, so I'll substitute mod m. Okay, mod m is there, so this is equal to, okay, now this is again integration 0 to Now s is going to change to x. So I'm going to take this as x divided by 1 plus x square. Okay, sine s is going to change to x, and x is going to change, this is going to change to x, this is going to change to m, and obviously this will change to dx. So this is m dx, or integration 0 to infinity x mx divided by 1 plus x square dx can be written as pi by 2 e raised to minus mod m. So please check, students, is it right? We have calculated the right term, that is integration 0 to infinity x sine mx divided by 1 plus x square dx. So m is greater than 0. So this is what we get the answer, students. So is it clear? I think this is quite easy. Yes, students. Please, if you have any doubt, ask me, beta. Yes. If you have any doubt, please ask me, students. Okay, no doubt. Okay. So then we will continue. Next example, you can see this is also quite easy. So I think within 15 minutes, more than enough to solve this types of example. So example 2 we will go. So now you can see again, find the Fourier sine transform of to e raised to minus ax divided by x is greater than 0. Okay, let us see here, students. Fine. So again, you can see direct question these are. There is no confusion in the question. Whenever they ask sine Fourier transform, please use this formula. Fs of s is equal to integration 0 to infinity f of x sine x. Okay, fine. So we'll start now. Solution. So always, students, please write down formula. Okay. So now, after writing the formula, that is, let f s of s is equal to integration 0 to infinity f of x sine sx dx. So I'm going to substitute the function. This is our x, and please remember f of x will be given here, so it is e raised to minus ax upon x. Just substitute. Okay, so this will be written as fs s is equal to integration 0 to infinity e raised to minus iax divided by x sine x dx. Remaining terms, please keep it as it is. I will take this as equation 1. Now, can anybody tell me how we are going to simplify this now? Yes? Right, because we don't have any formula. So integration, I will tell you any shortcut method. We have to modify. That's it. With that it should come to the formula method. Like it should be appear like formula, and then we can substitute the formula. Otherwise, you cannot solve this integration. It should be solved by using some formulas. For that, yes, we don't have any formula for this. Yes, we have only formula, that is e raised to ax sine bx dx. This formula we know, therefore we have substituted. But here in this case, we cannot use this, students. Please remember. So for this, what I will do, I'll say that we cannot evaluate this integral directly. Is it clear? Hence, what I do, I use Leibniz rule of differentiation, or okay, it is also known as Leibniz rules of differentiation. I will show you, I will tell you how you are going to differentiate. See, when this integration you are going to differentiate, you are going to differentiate on both the sides. Is it clear? But if you are going to differentiate outside the integral, this is a definite functions you can see. Yes, it is d by ds with respect to ds. Please remember here I would write with respect to yes only. Okay, so this is equal to, but please remember when I take the differentiation under this integral, it will become automatically the partial differentiation. Means wherever dou upon dou s, wherever there is s term, that is sine s x dx. So you may be asking that, sir, why we are using this differentiation only for yes? Because you go and see that in the next 2 3 steps it can be evaluated easily. So for your for simplification easily, we use this type of rules. Okay, so rule of differentiation or Leibniz rule, what we say, students, wherever yes is there, yes, you can see only sign yes we have. Other terms are x. So partially means only for particular variable, that is yes variable, we are going to differentiate, students. So remaining terms, please keep it as it is. Only for this term, I am going to use the differentiation. Though minus ax upon x, keep it as it is, students. Only differentiate this one. So dou upon dou s, this is a partial differentiation denoted by, okay, so this is equal to, I think you know that coefficient will be multiplied outside. So what we are going to take, coefficient is x here, so I will take x outside. So you are going to get the differentiation of sine sx as this is cos s x. So you can see x, so I don't want this divided by x, therefore I'm going to use this method or rule of differentiation. So this will be x cos s x dx. Only this part you can see part is differentiated. The textbook they have given directly. The step is missing. So please note down this, very very important. Now you can see the next step, this x will get cancelled. So this will be now equal to integration 0 to infinity e raised to minus a x cos sx dx. Now you can see this is of the standard form, right? So you can write up or you can use the formula. I think you remember the formula e raised to ax cos bx dx. So this formula, I think you remember this formula, e raised to ax. Please check the formula once again. A square plus b square a cos bx plus b sin bx. Yes, students, is it clear? See, I am not applying the integration. Now, after modifying, I can apply this integration when it comes to the standard form or standard formula. So you are going to use this type of formula. So now you can see here, students, a, I'm going to substitute here the values now. This is equal to e raised to minus ax divided by, yes, see this is a is equal to minus a they have given, it is clearly mentioned. Yes, b is equal to yes. So these two values you are going to substitute in this integral. Okay, square minus a square is a square only, so I'll write a square only plus b square. B is nothing but yes, so I'm going to write here yes square. I'm just substituting the values here, student. In this, I'm substituting a is equal to minus a, b is equal to yes. Please remember. So in the bracket, you can see a cos sx plus s sin sx. So this is our standard integration formula in the interval 0 to infinity. So please remember this, students. Every time you are going to modify this integration, unless and until you don't modify this, students, it is very difficult to integrate. So you have to modify such by using some formula. Yes, by using some formula you should integrate this very easily. So now you can see I'm going to substitute this equal to. This is e raised to is there means e raised to minus infinity. If I substitute, this will be 1 upon e raised to plus infinity. Am I right? E raised to minus infinity is 1 upon e raised to plus infinity. Okay. So this is equal to 1 upon infinity, which is equal to 0. Yes. When I substitute x, this full term will become 0. Okay. So I will keep this 0 as it is. Okay. Then I will go to the next term. So this is okay. Now again you can see here, students, I will substitute the value, that is e raised to 0. Now this will become minus 0, or e raised to it will become 0. E raised to 0 is nothing but 1. So I'm going to substitute x is equal to 0 here. Become 0 1. Sorry, e raised to 0 will become 1. Here is plus s square as it is. Okay, now x is again 0. So now I can see this is cos is there. Cos will become, please note down, front. So this is minus a, I will keep it as it is, into 1. So I'll write 1. Then plus x is 0. So you can see sine 0. Sine 0 is 0. So this is going to become 0. Yes, students, you can see here. Okay, now we'll simplify this. So we can see minus into minus, but you can see minus into minus will become plus a upon a square plus s square. Is it clear? Yes, but please remember this is not your Fourier sine transform, because we have here d upon ds f s of s. This is a derivative, or we also take this as f dash, which is not Fourier sine transform. Only this fs of s is required, students. So what I have to do here? Yes, very very important. How to simplify this further? Yes, by using integral sign. So integrating both the sides, you can see here, students. Yes, this differentiation will go. Integration and differentiation are reverse. I think you know everyone. So directly I am going to get this Fourier transform Fs of S is equal to, integrate this, students. Now how you are going to integrate? Integrate a upon a square plus s square ds with respect to s. Please remember, students, integration with respect to s only. Okay, so this will be equal to a, I will take outside, integration 1 upon a square plus s square ds, as integration of 1 upon a square plus x square dx. As you remember, 1 upon a tan inverse, yes, x upon a. Yes, run. Do you remember this integration? Okay. So I'll substitute the value here. Now x is here, yes. So I'm going to take this as a. Integration will be 1 upon a tan inverse. Sorry, tan inverse. This is s by a. Yes, friends. Now you can see. Yes, please remember some constant will be there. Definitely it will be 0. We'll consider it. So we can see a will get cancelled, and we are going to get the answer, that is f s of s, that is Fourier sine transform is equal to tan inverse s divided by A. So here you can see this is our answer. Yes, students, any doubt, please ask me. So we'll keep this constant C equal to 0 also, or for this calculation you can put S is equal to 0. That implies C is equal to 0. Therefore, we get this answer. That also we can show. No problem. Is it clear, friends? If you have any doubt, please ask me, students. Yes? Any doubts? Yes, this video